In this section, we're going to cover the standard forms of equations for ellipse. Before you could copy down the chart, please make a note. I would highlight this. The standard form for an ellipse centered at h comma k, where a is greater than b. So this is the most important information you should have when in terms of writing your equation for an ellipse, where a is greater than b. Alright, so in this chart, when you're copying this down, make sure you copy exactly what it's shown here. What I mean by, you see how there's an equation on the left section and there's another equation on the right section. Pay very close attention on how it's labeled, and I'm going to talk about the equation and what's the difference between these two. And here's why. If you look at these two equations, this one is the square of x minus h over a squared plus y minus k squared over b squared equals 1. Now it's identical, very similar, not identical. So it's very similar to the one on the right. X, the square of x minus h over b squared plus the square of y minus k over a squared equals 1. So if you were to analyze these two equations, 99% of the time it's identical. But the only difference is if you look at the a squared and the b squared, and then on the right, you look at the b squared and the a squared, you see how where they're located. So basically, between these two equations, they were flipped. Now, this information will help you determine how to set it up. So, it goes back to the sentence to where I told you to make a note about this, where a is greater than b. What it means is where the a squared is located, meaning that's the major axis. So since the a squared is on the x, that means it's going to be a horizontal line. So your major axis is going to be a horizontal line. On the right, your a squared is underneath y minus k. So that means your major axis is going to be a vertical line. So if you look at the two graphs below, the a squared is underneath the x minus h. You can see that the horizontal line is longer than the vertical line. The one on the right, your a squared is underneath the y minus k. That means that the major axis is vertical, which is longer than the axis that is horizontal. So once you're able to identify or distinguish between these two equations, make sure to know that there's separate equations for parts of it, such as center, foci, vertice, co-vertice, major axis, minor axis. Same thing applies to parabolas. Once you know which one to work with, which standard form, now you're able to use correct formulas. So same thing here. Once you're able to tell between the two equations for ellipse, you're able to use the correct formulas for especially foci, vertice, co-vertice, major axis, and minor axis. So let me go over this. So based on the one on the left, where the a squared is underneath x minus h, the orientation means horizontal major axis. So the major axis is a horizontal line. The center is h comma k. The foci is h plus minus c comma k. So what it means by h plus and minus c comma k, it means that you actually have two focus points. So that means you're going to do twice the work. So you're going to do one for h plus c comma k. Then the second one, you're going to do h minus c comma k. So that's how you're going to get your two coordinate points for your foci or focus points. So let me repeat. You're going to do h plus c comma k. And then the second one, you're going to do h minus c comma k. The same process you would do for vertice, you would do h plus a comma k. And then the second one, you're going to do h minus a comma k. Your co-vertices, now it's going to be h comma k plus b for your first point, and then your second one will be h comma k minus b. So you should have 2 points for foci, 2 points for vertices, 2 points for covertices. Major axis is y equals k. Minor axis is x equals h. The ABC relationship is c squared equals a squared minus b squared, or c is equal to the square root of a squared minus b squared. Make sure you take a note of this. Make sure you have this and have it memorized. Now, let me talk about the parts on the right. So for the second equation of the ellipse, the orientation is a vertical major axis, meaning that the major axis is a vertical line going up and down. The center is the same, h comma k. Now for foci, it's going to be h comma k plus minus c. So again, you got to do 2 points. The first one is h comma k plus c. The second one will be h k minus c. That's your second point. Same process with vertices. Now it's going to be h comma k plus a, and then h comma k minus a. So that's going to be our 2 points. Covertices is going to be the same process. It's going to be h plus b comma k, and then the second one will be h minus b comma k. Next is the major axis, where it's going to be x equals h, and then minor axis will be y equal k. The relationship between a, b, and c is the same as the one on the right. C squared equals a squared minus b squared, or c is equal to the square root of a squared minus b squared. So make sure to have this information in your notes. Make sure to tell the difference between these two equations, as I will frequently ask you, how would you know which equation to use and why? Because once you know which correct form to use, therefore, you know the correct formulas when it comes to foci, vertices, covertices, major axis, and minor axis. If you don't know the correct formulas, if you cannot tell the difference, you won't be able to know which correct formula to use, and you may end up with the wrong answers, even though the process, the algebraic skills behind it is pretty simple. So if you did all this work and you found out that you're using the wrong formulas, that means you would have to start over and use the correct formulas to get the correct answers. So again, make sure to know the difference between the two equations in order to use the correct formulas for foci, vertices, covertices, major axis, and minor axis.